We're in section 11.4, which is the comparison test. We have example 1 part B, the series of n over n squared minus cosine squared. So we did the integral test recently in the section before, just to appreciate that if you try to take the integral of this a sub n, it's not going to be doable. So that's not helpful. Comparison test, one thing to check out is that the a sub n is greater than 0 for n greater or equal to 1 always. So we got that going for it. The next thing is we need to kind of try to characterize what that a sub n is doing and try to find a comparable series that we think behaves like our a sub n. So a game you can play is which terms dominate when you have a fraction in the numerator and the denominator, and just make a ratio of those things. Looking at the top, of course, we just got the one term. Down low, looking especially as n gets big, the cosine of n squared is going to be less and less of an issue. It's just a small value that's being subtracted from n squared, which as n gets bigger is going to definitely dominate here. So all that was to figure out a comparable b sub n that we can compare our series a sub n with, which is the n over the n squared minus cosine squared. Alright, so just kind of writing some of this down. This is a small potatoes here as n goes to infinity. aka n squared dominates. So for b sub n, let's choose n over n squared and see how that goes. So next thing, sometimes things can then simplify because it's simpler. And so n over n squared simplifies to 1 over n. So we're kind of taking a guess here that maybe our series kind of behaves like this series of 1 over n. Alright, so now we start our test, and one thing you don't necessarily have to do here, but at some point you need to determine if the series for which you're comparing the b sub n term to the a sub n, if that converges or diverges. So the series 1 over n is the harmonic series, and that's a special case of the p-series, and all this comes up a lot, so maybe just remembering the harmonic series diverges is worthwhile. So then the next thing is we're going to do our comparison. Hence the name of the test here. And so I always like to write my a sub n first, although it doesn't matter. The nice thing, however, on the formula sheet, I'm just going to scroll down because I got it down here, is all these comparisons on the formula sheet do have the a sub n first, so that's actually probably a good idea, not just a personal preference here, given that formula sheet. Anyway, my a sub n is n over n squared minus cosine of n squared. We're comparing that to n over n squared, which reduces to 1 over n. Alright, so even though this reduces to 1 over n, I did write it as n over n squared on purpose initially because it's easier to compare the two series that way, their general term. So notice the n's are the same, and then the bottom part, or the denominator, is a little different. So if you compare n squared minus cosine squared to n squared could possibly be a little bit smaller, or equal to technically, as compared to the n squared for n greater or equal to 1. So making this comparison, overall we have the same n, divided by something smaller versus something bigger, overall we'd get something bigger for our a sub n as compared to our b sub n. So then I can track my inequalities up to make the comparison. So the idea here, we have our harmonic series, which is divergent, and this inequality here is in the correct direction to help us, and I'll scroll down here so you can see that. So because our a sub n is greater than or equal to b sub n, and our series of b sub n is divergent, then we can conclude, because this is in a divergent column, that our series a sub n also diverges. And the idea is we have our a sub n term being even bigger, potentially, than the b sub n, and its series diverges. So then certainly this one will too, because we always have positive terms. So it's going to infinity, and then this one's also going to be going to infinity. So we can conclude that our series, which is the a sub n here, is divergent, by the comparison with the harmonic series, the series of 1 over n.